All right, welcome back, everyone. Today, we're going to pull back the curtain on one of the most critical yet kind of invisible jobs in all of tech, site reliability engineering, or SRE for short. They're pretty much this secret sauce that makes your favorite apps and websites actually work. So let's kick things off with a feeling I know we've all had. Oh, you've totally been there, right? You're about to score the winning goal in a game, you're binge watching the season finale, or you're finally about to check out your online shopping cart, and boom, it crashes. It is so frustrating. And that moment of frustration, that's exactly where the story of SRE really begins. Okay, so to really get what SRE is all about, we have to understand the problem it was built to solve. And honestly, the best way to picture it is to think about a Formula One race car, because at the heart of any high-performance team, there's this core tension, the constant battle between going faster and, well, not breaking down. So, picture this. On one side, you've got the designers. We'll just call them developers for our story. Their whole job is to innovate, add a bigger engine, a new wing, anything to make the car faster. Then, on the other side, you have the local mechanic, the traditional operations team. They're the ones getting the frantic call at 3 a.m. when that fancy new engine just dies. You can almost hear them yelling at each other, right? You're slowing us down versus you're making everything break. So this constant tug of war, it's at the heart of so many tech companies. But what if you didn't have to pick a side? What if there was a third way, a team literally designed to bridge this exact gap? Well, this is where our hero finally enters the scene. The solution is to stop thinking like you've got these two warring factions and start thinking like a world-class pit crew. That's it. Site reliability engineering is the Formula One pit crew for the internet. It's honestly that simple and that powerful. I mean, really think about it for a second. A pit crew doesn't just show up and fix stuff when it breaks. They're not just mechanics, they're engineers. They get the why behind how the car works. They're completely obsessed with data, tire pressure, fuel levels, lap times, everything. They automate relentlessly, turning a tire change into a stunning 2-second ballet. And this is the key part. They don't just hope for the best, they plan for failure and practice for it constantly, so that when it happens, it barely even affects the race. Okay, so how does this pit crew for the internet actually operate? It's not like they just show up and wing it. Nope. They have a very specific rule book, a set of core principles that turns keeping a service online from an art into a science. And rule number one, the big one, is you have to define your promises with actual data. So instead of some vague, impossible promise like, this app will never, ever crash, an SRE team creates what's called a service level objective, or an SLO. It's just a super clear, measurable target for how good the service should be. And this, right here, is where the light bulb really goes on for most people. A bad promise is just, the video will load fast. I mean, what does fast even mean to you, to me? It's totally subjective. But a good SLO is razor sharp. 99.9% of videos will start playing in under 2 seconds. Bam. All of a sudden, everyone, the developers, the SREs, the bosses, they're all aiming for the exact same target. Okay, so once you have that super clear SLO, it unlocks what is, I think, the coolest part of SRE. Because once you've promised how reliable you're going to be, you've also, by definition, defined how much unreliability is okay. And this is what we call the error budget. It's literally an allowance for taking risks. And here's where that abstract percentage gets real, like really real. If your SLO is 99.9% uptime, your error budget is that little 0.1% left over. In a typical month, that works out to about 43 minutes of acceptable downtime or slowness. And those 43 minutes, that becomes a kind of currency that the developers and the SREs can use to negotiate. You see how this just completely changes the conversation? It's not an argument based on who's more nervous or who's more optimistic anymore. The question becomes dead simple. Do we have enough minutes in our error budget to try out this risky new feature? And if that budget is all used up, guess what? All risky new stuff gets frozen until the system gets more stable. It's a self-correcting system. So if they're not just fighting fires all day, what are SREs actually doing with their time? Well, a huge part of it is fighting a very specific enemy, and that enemy is called Toil. Toil is any kind of work that's manual, super repetitive, and could be automated. Think restarting a server by hand or copying and pasting the same thing over and over. And let me tell you, SREs absolutely hate Toil. Let's take a perfect example. Imagine a massive new video game season is about to launch. The old way, the Toil way, is some poor operator sitting there totally stressed, manually adding servers while millions of players are trying to log on. It's slow, it's messy, the SRE way. An engineer already wrote a script for that. The system just scales itself up and down, and the SRE can go grab a coffee and actually focus on bigger problems. But look, systems are crazy complex. Things are going to break. It's inevitable. The real question is, what happens next? And this brings us to a huge cultural pillar of SRE, blameless postmortems. When something goes wrong, the goal is always to learn, never ever to blame. So this means the whole investigation, it's never about who screwed up. No. Instead, the team pieces together a factual timeline of what happened. They dig deep for the real, systemic root cause. Maybe it's a gap in the testing process or a confusing tool. And then they figure out how to change the system so this kind of problem can't happen again. And I mean, the difference here is just night and day. A culture of blame points a finger and says, Bob pushed bad code, so let's ban Bob from doing that on Fridays. What does that do? It just makes people hide their mistakes. But a blameless culture says, hey, our system let this bug through. Let's fix the system. That's how you actually get better. Okay, so we've covered the big ideas, the core principles. Now, let's put it all together and see how it works in a massive, high-stakes, real-world scenario you're definitely going to recognize. So let's set the scene. It's midnight. A brand new season of a show like, say, Stranger Things is about to drop all over the world. Millions of people are sitting on their couches ready to hit play at the exact same second. The potential for a massive, catastrophic global crash is huge. So, what does that SRE Pit Crew do to get ready? Well, they model the expected viewership to plan for capacity. They make sure all their automation is ready for giant traffic spikes. They have dashboards set up to watch every critical SLO. But then we get to the really wild part, chaos engineering. Yeah, you heard that right. They intentionally break things in their own system, on purpose, in a controlled way, just to prove that their automated defenses work. It's basically a fire drill for their entire global network. It's amazing. So, after all of that, if you're going to walk away with just one thing, what should it be? Just remember this. SRE is the practice of using software engineering, so code, data, automation, to solve operations problems. At the end of the day, it's all about treating operations not as a manual task, but as a software engineering problem. You can see it's a really powerful mindset, right? It shifts the whole focus from just reacting to problems to actually engineering a system that's designed not to have them in the first place. And that really leaves us with one final thought for you to chew on. What part of your world, your job, your team, maybe even a personal project, could use its very own pit crew? Thanks for tuning in.